so 4.2, we did, I believe, investigate all the characteristics of um, y equals x squared plus k, y equals ax squared, and y equals ax squared plus k. And what I am going to do now is the summarization of the whole thing. So what I want you to do is I want you to open page 5. So it is 4.2, page 5. The page number is actually on the left bottom corner. Okay, left bottom corner. Okay, so then let's take a look at, actually let's move this. That's a lot better. Okay, so let's take a look at y equals x squared plus k first. Now remember what a does. Okay, so in front of the x squared, the sign here is positive. Okay, now if you have y equals x squared plus k and nothing is attached to the x, then the vertex will be 0 comma k all the time. Axis of symmetry is always the x value of your vertex, so x equals 0. Direction of opening. Now remember the first thing I said was the sign of the x squared is positive, so it is always up. Domain is x such that x is an element of real number all the time. For the quadratic functions that we are doing currently, the domain will be this. The range, however, will change. So the range is that y such that y is greater than or equal to k, and y is an element of real number. Now remember this, okay? If the graph is opening up, then every single y value is higher than your vertex, right? Because it's opening up. Therefore, y is greater than or equal to k. Now, in terms of the x-intercept, okay, in terms of the x-intercept, you should be able to find this, okay? However, the easier way of doing this is, remember x-intercept is always a number, comma, 0. Therefore, it is number, comma, 0. Now, there are 3 cases here. So 1. Now, when k is greater than 0, okay, then there is no x-intercept. 2, if k is equal to 0, okay, if k is 0, then the x-intercept will be 0, comma 0. 3, now I don't have enough space. Hopefully you have enough space somehow. K is less than 0, then the x-intercepts are negative, positive, so plus minus square root of k, comma 0. Okay. Now, so there are 2 x-intercepts. One, square root of k, comma 0. Another one will be negative. This is negative. Okay. Negative square root of k, comma 0. So this is k. Sorry for the small letters. Okay. The y-intercept is always 0, comma k, whatever the k. Now, description of the transformation. So we say it moves up or down by k units. Okay, so remember k, oops, I can see that, but if I have y equals x squared plus k, k always does up and down movement. Now, in this case, it's opening up. As I said, it's the minimum value, so the minimum value will be whatever the number, okay, but this case it's 0, comma k. So simply it's the same thing as the vertex. Now occurs when? Well, simply x equals 0. Now the graph will be it can be up here, okay, when k is greater than 0. It can be down here when k equals 0. And it can be down right here. And that's when k is less than 0. So there are 3 cases. 1, 2, 3. Okay. Now, pretty much the same thing as the second table. Okay, I'm going to go a bit quicker. Now the vertex here, I don't have anything added to the x's, so it will be 0, comma 0. Axis of symmetry is always the x value of 0. Direction of opening, it will be up if a is greater than 0. It will be down if a is less than 0. Okay. Now the domain, always domain is x such that x is an element of real number, whereas range, now the range is always following the vertex. So there are two cases. I'm going to put two cases. Y such that y is greater than or equal to 0, an element of real number. And this is when, so if a is greater than 0. Okay. Now if a is less than 0, so if a is less than 0, then the range will be the opposite way. Okay. That y such that y is less than or equal to 0 and y is an element of real number, and this is when a is less than 0. Okay. Now x-intercept will be simply just 0, comma 0. Okay. The y-intercept will also be 0, comma 0 in this case. Remember, these two are influenced by whatever that is added to the x. So it will be h or k, or h and k. Okay, so it is affected by h and k value in the function. Now you're going to see what it means in a bit, maybe in about a couple of days later. Now, description of the transformation is this. It is stretched vertically by a factor of a if the absolute value of a is greater than 1. Okay. Now the other way will be the compression. Okay, so compression vertically by a factor of a. Okay, if the absolute value of the a is less than 1. Okay, so it is absolute value is less than 1. Now minimum or maximum value, obviously it is minimum when it is opening up, so it's min at 0, comma 0 when a is greater than 0. Now max at 0, comma 0 when a is less than 0. Okay. Occurs when, well, simply x equals to 0. That's what's happening. Now the graph will be two cases. Okay, I'm just going to draw the first one and the second one at the same time. This is when a is greater than 0. Okay, and this is when a is less than 0. See, both are actually at the, both are actually at the origin. Okay. Now, then let's take a look at the second table, which is actually not the second table. Sorry, the third table. Now this is page 7. Okay, so page 7. Now this one is now combined with the first two. Okay, so I'm gonna go even faster with this one. The vertex is still 0, comma k. Y is 0. There's nothing added directly to the x, but it's outside, so it's 0, comma k. Now axis of symmetry is always the x value of the vertex. X equals 0. Direction of opening is pretty much the same as previous. Okay, so up if a is greater than 0. Down if a is less than 0. Okay, it's pretty much the same. Domain is the same, x such that x is an element of real number. Now the range, again, this is the same as the first graph, okay, the first table. So the range is y such that y is an element of real number and y is greater than or equal to 0. Sorry, these were supposed to be switched. If okay, a is greater than 0. Now the other one, this is the first case, the second case, Okay, the other one will be, I'll just put this way, same way. Less than or equal to 0 if a is less than 0. Okay, so you should be able to figure this out by investigating it on your own. Okay, now the x-intercept will be depending on the k. So since I don't really have much space, I will just say same as y equals x squared plus k. Okay, I'm just going to put it this way since I explained it already. Y-intercept, it's the same as y equals x plus k case. Okay, nothing really different. Now the description of transformation from this is the same thing. It's the combination of the of both. Okay, so the one is vertical stretch or compression. Okay, or compression by a factor of a. Now remember, it depends on what the a value is. Okay, it depends on what the a value is. Now the second transformation here is then the vertical shift or vertical move or move up and down. It's up to you. Vertical shift or translation as well, shift or move up or down by k units. Now maximum or minimum value, it's pretty much the same. Okay, it's pretty much the same. So if it is max at the vertex point, which is 0 comma k, if a is less than 0. Now min at 0 comma k if a is greater than 0. Occurs when? Well, simply x equals 0. Now the graph, I'm going to draw graph of these transformations. So I have x and y. Now I will probably have this as a is greater than 0, k is greater than 0. Okay, now I'm going to use another color. This is a is greater than 0, k is equal to 0. Lastly, I have, then this is a is greater than 0, k is less than 0. Now I'm going to draw another graph on the side. Okay, now I'm going to use a red pen. So for the graphing part, I'm going to draw another grid, y and x, and the reason is I need to, and I want to distinguish it. Now this is red, okay, red. One is that this, okay, and this is when a is less than 0, k is less than 0. Second one that I want to show you is a is less than 0, k equals 0. The last thing is a is less than 0, k is greater than 0. Okay, so these are the cases for y equals ax squared plus k. Okay, you should be able to figure these out already. We're going to discuss, well, we already discussed it in the class. Okay, all right, thanks for watching. Bye.